Hey guys, in this video I'm going to show y'all how to work this buffer titration problem for one volume of titrant added, and then I'll show you how to do it in Excel for a series of volumes. So the first thing you want to do is write down what you're given. So this is the hydrofluoric acid fluoride buffer system. The pKa of hydrofluoric acid is 3.1. The buffer is going to be 1 molar. The initial volume of our solution is 10 milliliters. And the concentration of our titrant is 1.3 molar. So the first step is to find the number of moles of the titrant that you add. So for the first milliliter of our titration, we are starting with 1.3 moles per liter of NaOH. So to convert that into moles, we need to multiply it by the amount that we're adding, which is 1 milliliter, and then convert milliliters into liters. So there's 1,000 milliliters in 1 liter, and that's going to give us 0.0013 moles. So that number of moles is going to react with the hydrofluoric acid to produce more fluoride. So the second step is going to be finding the new concentration of your weak acid and its conjugate base. So the new concentration of your conjugate base is the initial concentration, so 1, plus whatever amount of fluoride is created from the reaction. So that is the number of moles divided by the new total volume. Our initial was 10 milliliters, so that's with 1 milliliter added going to be 11 milliliters. And then again, we want to convert milliliters to liters, so we multiply by 1,000. And that's going to give us 1.118 molar. We'll do the same for our weak acid. Again, NaOH is going to be stealing the protons from that, so you have your initial concentration minus however much NaOH you added. So that's going to be 0.0013 again. Again, dividing by our initial volume, or sorry, our new volume rather. And again, multiplying by 1,000 to convert milliliters to liters so we can get molar. We get 0.822 molar. Now that we've done all of that, we can move on to the final step, which is what you actually want to find, the new pH after adding that 1 milliliter of titrant. So if we recall, pH is the pKa of the buffer, so that's 3.1, plus the log base 10 of what we found here, divided by what we found here, and if we plug that into our calculator, we get a new pH of 3.203. So that's how you would do it for each step. All you would have to do is plug in the amount that you add and the final volume for each of these, and you'll get the same result every time. Now we can easily do this in Excel instead if we set up our table like this. So first let's put in our information. We're dealing with hydrofluoric acid with a pKa of 3.1. The initial concentrations of our acid and conjugate base are both 1 molar. And the molarity of our titrant is 1.3 molar. The initial buffer volume is 10 milliliters. So the first thing you're going to want to do is start with a list of amounts of titrant added. Usually I do this just by doing 0, 1, 2, and then dragging down all the way to the point that you want to stop. For our case, the titration is going to basically be over at 33 milliliters. Then the next thing you want to do is, just like before, calculate the number of moles of NaOH. So you have your volume. Always remember to do equals. You have your initial volume, and then that is going to be multiplied by the molarity, so that's 1.3. And then you are going to want to remember to convert that to liters, so divide by 1,000. Now, of course, our initial volume is 0, so that should give us 0. Our total volume is going to be 10 milliliters plus however much. Plus however much you added. So 10 milliliters. Our concentration of weak acid is going to be 1 plus however many moles you added. And then divided by the total volume. And again, converting to liters, we want to multiply by 1,000. By the same token, we're going to do that for our weak acid. So it's 1 minus the number of moles of NaOH we added times our total volume, divided by our total volume, times 1,000. And then let's just double check to make sure our formulas are right. Okay, so we have moles divided by volume times 1,000, moles divided by volume times 1,000, concentration divided by 1,000 times volume. All right, all good there. So then we can enter our Henderson-Hasselbalch equation. So we have 3.1 plus the log, open parentheses, of this ratio here. And we have 3.1. Now the great thing about Excel is you can just highlight all of these, go to the bottom right corner, and drag it down, and you get a whole table of values already done for you. Let's just double check to make sure all of these results make sense. So we didn't add any acid or base, so these ratio here, these should add up to 2 no matter what, and we pick some simple examples. 1.3 plus 0.7, that makes sense. 1.8 plus 0.2, that makes sense. And then if we go to our pH results, we can see that the rise in pH is gradual, maybe by 0.1 each time, really a little bit less than 0.1 each time, all the way until we get to this last step where we see a much bigger jump in our data. Now for y'all's lab, of course, the concentrations, the acid you're dealing with, and the concentration of the titrant are all going to be different. But as long as you use those as simple values and then make sure that you use the formulas, this should apply to any buffer system.